June 20th, 2016. You're looking at the ACE satellite proton monitor, guys, and this is giving us a heads up of what's coming in the solar stream from the sun. Depends on the speed of the solar wind or coronal mass ejection or solar flare or filament release. It can give us from 45 minutes to a couple hours of heads up as far as what's coming from the sun towards our planet. To the right, as we look at these images from the Solar Dynamics Observatory, which gives us the image as if we're looking at it from the Earth. In other words, on the Earth's side of the sun. We've had two filament releases to the right, and they will create a coronal mass ejection, or the surface of the sun, and that's measured in density. When you see your solar wind, normally you'll have a density count involved in that. The thicker the density, the more impact on the shields of our planet. Again, close up and a slow-mo of these two events. If they had been Earth-facing, I would be a little more concerned, but again, this energy does radiate outwards. If not, the satellite that we saw at the beginning of the video, the ACE satellite with the proton warning, would not be picking up these bursts. Do you understand what I'm saying? A lot of people say, well, there's no effect on our planet, but it is. And usually when we see multiple filament releases in the last year, you can look to CERN and see if they're running at extremely high power. Now, this satellite does not have the last few images of the day. We're going to switch to two other ones. We're going to switch to LASCO, and you'll see we've had a topside eruption also. But again, SDO is the clearest pictures as far as close-up. A couple of the other satellites, though, give us an hour or two newer images. Again, both of these eruptions were connected. You can see the larger filament release come back and then cause that burst. Now, that smaller burst, guys, was 10 times the size of our planet. Again, same satellite, different camera. As a matter of fact, it's 3 cameras overlaid. You can see these dark blue images, and that's why it's been so hot. At the top, at the bottom of the sun, that's pure solar wind pouring through the magnetic canopy of the sun. In other words, it's like the cloudless area of the sun, and that magnetic stream is pouring straight at us instead of being tied up into these magnetic canopies. Magnetic canopies, guys, are released, and most of them turn back into the sun. See these great winding loops as we look at these darker filaments. But with the solar minimum and the sunspots down, and then CERN being down until a couple of days ago because they overheated, we saw the sun try to normalize. And we see those days, but that's why it's been so hot. We're summer solstice, extremely high amount of solar wind coming at us, straight at us. Even though you have a solar minimum, you can have that effect. Now, as you see Venus moving to the left behind the sun, you saw a topside explosion. These are LASCO C2 and C3 images. Notice your timestamp. It goes a little further in the day. The ACE satellite in the last couple of bursts is what this was picking up. We didn't see it on the SDO because, again, the timing of the images. We'll switch to stereo A. Guys, that's on the opposite side of the sun as our planet. It's amazing. We're at 1 AU on this side. There are the stereo A satellite is in our orbit, but on the other side, both 99 million miles from the sun. Now, everything's to the opposite side. You see that because it's backside. The top burst, though, was what looked the most impressive in the last few frames. Notice your timestamp. Now, the Earth is in the green dot at the very bottom of this, and you see Venus there as it moves around the sun. But stereo A has finally come back this year from behind the sun, and we're getting these images that you see, and Mercury to the right. Now, let's switch to CERN. They're running at the maximum power they've run at since we have seen them. And there are 240 bunches at both 4.5 and 6.50 teravolts right here. You can see the collisions just below this, but that green line, guys, that's energy in tera-electron volts. You can see it's 6.5. That means per beam, which is in the red and blue, creating the 13 tera-electron collisions. Now, luminosity is very high. This is the beam a few minutes ago as I was recording it. Now, that would put this timestamp. Notice 02630. That would put it at 6:26:35 this afternoon on the East Coast, or 5:26:35 here. We're dealing with time there in Switzerland at CERN. These are the beams. Very tight. That means the energy is very high. They squeeze them down. Notice something in the bottom of this chart in the fat blue lines. That represents CERN. Atlas, the largest machine at CERN. See the color coding in the lines? It is being saturated. Check that out. And the luminosity will point that out as we switch to that page. But all four of the measuring devices, the machines inside this, are showing on this graph. Luminosity, bottom right. Notice red is the targeted, or what they're looking for. Green is what's delivered. Both the Atlas and the CMS, which are represented by the blue and black lines in the top, are reaching extremely high amounts of luminosity. That is measured by the power and the intensity and the number of collisions. The higher the collisions, the higher the bunches, the higher the luminosity. That has a lot to do with what these guys are trying to achieve. It's a fallen angel device. They're looking to open portals. They're looking for other dimensions. Now, notice the timestamp at this when they were starting to crank up. In the wee hours, night before last, on the 18th, they cut the time off just as it was starting to bend in at the bottom. Notice that pull on the southern poles. Then they've cut off images. We haven't had them in 2 days. Solar wind speed, 421.5 kilometers a second, and your density at 2. Now, yesterday it was at 473, but notice the density at 4.3. It was double the protons. That means the amount of energy in that solar stream was double. That's very fast. But guys, we did videos on Fort McMurray last month about the wildfires there. Now notice these timestamps. On the 16th, as this heat wave started building here in Fort McMurray in Alberta, Canada, near these tar sands, we started to see the fires break out. But on the 16th, it was amazing what had started to happen. And that's about the time these fires started up in Arizona, New Mexico, California, as we look at that. But guys, look at this. Now, we haven't heard much mainstream news on Fort McMurray fires. This is the 16th. Notice your timestamp, bottom left. Look at this. It's as if it's burning right back through the same areas. Guys, is this the tar sands burning through the peat moss or the peat bog? But look at that. That's as intense as I've seen it from day one. In some of these areas, we're already burnt over. So is it, again, firing from this bog or peat bog having to do with these tar sands? Check that out. It was almost out. And the last few days before this, it appeared to be almost gone. But sometimes it's very cloudy. Now, on June 20th today, and we'll get another satellite loop image before the day's over, you can see where the fires are in Arizona and New Mexico. This goes back to the 16th, and both Arizona and New Mexico, 3 different fires started firing up then, having problems. Now, this heat is intense. It's dry there. They're not getting any moisture. You're getting the solid solar stream bombardment. Our shields are weak. We are at summer solstice today, which is the longest day of the year, guys. It is, but by far it's not the hottest. We see that later in July and August, normally. So how is July and August going to be? This is Santa Barbara fires from space. Let's pull this back up. Now, on the 16th, as they were firing up, it was blowing offshore. But that's changed, and we'll look at a couple of different satellite images for you guys in California there. But that has changed. You see the winds on the 17th started to kind of stay in one area, and as it goes through, but to the 18th, starting to blow inward. Now you can see on the 20th here that this is it's still just getting daylight on the 20th in that satellite loop. But here you can see from this particular image, they develop here, and they're moving now with the wind eastward, not offshore, but back to the right. Now, so you guys watch that. I really haven't done a lot of report on the fires, forest fires, guys, because it is mainstream. I mean, they've got it covered. They got satellite imaging. They've got helicopters on it and all this. I just try to look at it from my perspective to give you an idea of what we're dealing with. And again, these coronal holes on the sun, these vast openings of the magnetic canopy, have a lot to do with this. Now, it also has to do with this, the magnetic wobble of our magnetic field. 2013 in the center, you've seen this on many of my videos. Each year that has expanded outward. That causes more extreme summers and more extreme winters. We need to pay attention to this. This last section of that red line is what's expected in 2016. They really have no idea. That's why it's just a straight circle. All of these little dips and dives are earthquakes or other things. That the one in the top right corner was the perihelion of ISON is it on November 28th, 2013 as it went around the sun. We've talked about that before. I think it created a magnetic slip. Look at the double right angles. You see that? For a second there, everything was slipped out. This also occurred back during the Fukushima quake, guys. The Earth shifted. We have not had an Atlantic hurricane come into the Gulf of Mexico since the Fukushima quake. If you remember, certain airstrips had to be shut down, certain runways, so they could change the numbers which indicate the magnetic north markings so it wouldn't throw the pilots off. The Earth changed on that day. Again, no hurricanes have come out of the Atlantic into the Gulf of Mexico since the day of Fukushima. Everyone has went and recurved up the East Coast. Things shifted. Things have changed. It's a heads up, guys. We're watching this. Let's watch for increased tectonic pressure on the plates simply because we're getting these solar flares. They're not that strong from the coronal mass ejections, but the shields are weak. CERN is running very hot. They're shutting down some of the instrumentation that we use to watch the effects. This is a heads up. Be safe. Fukushima has curved northward and went up the East Coast. Everything since Fukushima. Think about that. There's a lot going on this planet right now, politically, with the solar system, with the sun, and with CERN.